In this video, we'll look at the substitution rule for integrals or antiderivatives. If your integral is not a basic integral in x, you may be able to make a substitution, also called u substitution, where we set u is equal to g of x, then the differential du will be g prime of x dx. Using the substitution rule, we can change a composite or complicated integral in x into a basic integral in u. Simple substitutions for integrals are the reverse of chain rule for derivatives. So you could think of the substitution rule as the anti-chain rule. For simple substitutions, here are a couple of hints for choosing u. The first is that u is probably inside another function. And second, the differential du, which is g prime of x dx, appears in the integral, disregarding any constants. In this example, we want the antiderivative or indefinite integral of 3x squared times x cubed plus 4 to power 10 with respect to x. Since this integral is not basic, we can try a substitution. Here we can choose that u will be x cubed plus 4 because x cubed plus 4 is inside the power 10, and also the derivative of it, 3x squared, appears in the integral. So when we make our substitution, we will replace x cubed plus 4 with u, and we will replace 3x squared dx with du. So using the substitution, we went from this complicated integral in x to a basic integral in u. So now we have the integral of u to the 10 with respect to u, which is basic in u. So the antiderivative of u to the 10 will be u to the 11 over 11 plus c. And next we can put it back in x. So here the antiderivative is x cubed plus 4 to the 11 over 11 plus c. And it's up to you if you want to check your answer. You can take the derivative of the antiderivative and see if we get back the integrand. So we can take the derivative of x cubed plus 4 to the 11 over 11 plus c. To take the derivative, we will use the chain rule. The derivative of u to the 11 will be 11u to the 10 times u prime. So here we have 11 u to the 10. The derivative of x cubed plus 4 is 3x squared, and we kept the constant over 11. The 11 and the 11 will cancel, so we're left with 3x squared times x cubed plus 4 to the 10, which is what we had originally, so it's correct. In this next example, we have the integral of sine x times square root cosine x with respect to x. So here the integral is not a basic antiderivative rule, so we can try a substitution. So here we'll choose u to be cosine x, since cosine x is inside the square root. And also the derivative of cosine x, which is minus sine x, appears in the integral, disregarding the minus. From the equation du is equal to minus sine x dx, we can isolate what we have in the integral, and then we'll replace that with minus du. And also we'll replace cosine x with u. So we have negative times the integral of u to the half du, which is a basic integral in u. So we'll keep the negative in the front and take the antiderivative for u to the half, which will be u to the 3 over 2 divided by 3 over 2, or multiplied by the reciprocal 2/3, plus c. And next we'll just replace u with cosine x. So the antiderivative is minus 2 over 3 cosine x to the 3 over 2 plus c. And again, you can check your answer. You can take the derivative of the antiderivative to see if it gives you back the integrand. So we'll keep the minus 2/3 constant. We're taking the derivative of cosine to the power 3 over 2, which is like u to the 3 over 2. So the derivative will be 3 over 2 u to the 1/2. Now we take the derivative of cosine x for the chain rule, which will be minus sine x. So the constants and the minus signs will cancel out, and we're left with sine x cosine x to the half, which is what we started with, so it's correct.